Let's go ahead and we're starting a new chapter here. We're looking at notes 8.1. And we're looking at adding and subtracting polynomials here. We also want to be able to classify. So can I classify, add, and subtract? So as we go ahead and look at my chart here, and you might want to pause this to write this down, okay? I'm going to go ahead and just discuss each of these. The very first one, we call it a monomial, meaning that it has one term, okay? And this one term is the 6. It doesn't have a letter, so because it doesn't have a letter, we call it a constant. And again, it's one term. Let's talk about the degree. Because there is no letter, our degree is 0. I think maybe it'll make sense when I talk about the next one. The next example, we have 5x plus 9. Okay, 5x plus 9. This actually has 2 terms. The reason it has the 5x, terms are separated by addition, and it has the 9. So 5x is one term, 9 is another term, that makes up 2 terms. We call these binomials. And we have 2 terms, binomials. And the degree is 1. How we get the degree is we're looking at the letter and the exponent of the letter. This letter doesn't have an exponent written, which means it's automatically to the power of 1. And this is linear. So this is kind of when you learned your linear slope-intercept form, straight line equations. This is an example of a linear model. Let's go ahead and look at the next one. It's trinomial. Tri meaning 3, meaning that we actually have 3 terms separated by addition. So we have the number 3. We have the 7x, and then we have the 4x squared. Okay. Now our degree on this one is a 2 because it's the largest exponent that we see. The largest exponent that we see. We call this a quadratic, and this will actually be our next chapter is talking about quadratics. The next one is cubic. Because of that power, my power on the next one is a power of 3. The degree is 3. That's what makes it a cubic. It is only one term though. One term, so it has the name monomial. The one term is just the 2x cubed. And the very last one here that we can look at, we actually have 3 terms, but the biggest term or the biggest exponent is to the 4th power. But because there's 3 terms, we have named it a trinomial. So again, the naming of these, let me actually use a different color there. The naming of these is based on the terms. The degree, okay, is based on your biggest exponent. Let's go ahead and look at, that's classifying them. Let's go ahead and jump in and look at adding and subtracting. And honestly, this is nothing new. In order to add or subtract, we have to have like terms. What does that mean? That means same letter, same exponent. Because in example 1, I have my 3x squared and I have an x squared with the 5, I can put those together and I have 8x squared. And that is simplified and you are done. Now the problem below, example 2, we are adding, this is what we would call like the vertical model where you kind of stack like terms on top of each other. And we just add them, kind of our old traditional style. I always tell you to please change your negatives to plus a negative before you even begin adding. So if we add these, we're going to get 7,700. And we're going to get a negative 320x. Those are like terms. We can add them together. And we're going to get a 13.9 x squared. So the like terms can be added. We have simplified. There's nothing else we can do. This would be considered a trinomial because there's 3 terms. And again, we can only add if they have the same letter, same exponent. Let's look at subtracting, and that's it. Now for subtracting, we have to be very careful because when we're adding, it really doesn't matter which number you add first. When you are subtracting, it does. So as we look at example 1 here, first of all, do I have the same letter and same exponent? Yes. It's x3y, but my other one is also x3y. What number could I put in front of that? I can put the number 1. So this means 4 minus 1. Well, that would be just 3x3y. And if we wanted that y is to the power of 1 when our exponent is not written, it means 1. Let's look at example 2, and I'll tell you that example 2 actually started out horizontally. We have this grouping. We have to take away the other grouping. So I stacked it up. I went ahead and wrote my x cubed. I took this one first, and I wrote it on the top. I also made sure I changed all my subtract to add a negative. Then, of course, because we are subtracting, I put a subtraction symbol. This is probably the most common mistake, is we are subtracting here. And I lined up my like terms on the bottom. Well, out of this group, this second group, I don't have an x. There is nothing there. Think of it as 0. That's why I left a space. And out of my top, or my first set of parentheses, I did not have a constant. Think of it as 0. If it's not a part of the parentheses, then we can just apply 0 to it. So as we subtract these, and this is where things get a little tricky, I added in my zeros. I'm going to put a 1 in front of this x cubed because when it's not written, it means 1. And we are subtracting, and this is where things get a little difficult. Type them in. This is saying 1. That wasn't a very good writing on top. 1 minus 7. That's what that means, which is a negative 6x cubed. Plus negative 3 minus 5 is a negative 8x squared. Subtracting like terms. I should say combining like terms. We are subtracting here. Plus 5 take away nothing is just that 5x. Plus, and this one is a little tricky for some people, we're taking 0 minus negative 12, and you get a positive 12. This is our final answer. We have 4 terms. We cannot combine any because all of our like terms have already been combined. Negative 6x cubed plus negative 8x squared plus 5x plus 12. Again, pretty much a review. Adding and subtracting polynomials, and we can only add or subtract the ones that are like terms. That's it. Same letter, same exponent.